So we are live on page 158. So number one, first of all, experimental probability, right? P of E. Okay, P of E. So P of E means the probability of an event. That's all it means. P of E, the probability of an event. Okay, whether it's event, and they like A and B, so event A or event B. So it's just basically probability of some event. Whether it's flipping a coin, rolling a dice, or doing a spinner, that's your event, right? So it's the chances to win over the total, okay? Chances to win over the total, right? So if I'm rolling a dice, okay, there's 6 possibilities, right? And if I want to roll a 3, there's 1 3 out of 6, right? So it'd be 1 out of 6, okay? So if I'm going to win $1 million, if I roll a 3, there's 1 3, chances to win, out of a total of 6. Does that make sense? Okay. Now the outcome is just the result. It's just the result. And so when you guys did your spinner, that was the result, right? You spun. You got some results. You wrote it down, okay? The event is actually doing the experiment. So actually doing the experiment. Sample space is all possible outcomes. Okay, all possible outcomes. For example, if I were to draw if I got a deck of cards, right? I want to draw a card. My sample space is all 52 cards. Does that make sense? So my sample space is the total. So what am I going to do? If I'm going to draw a card, well, my sample space is all the cards. If I'm going to draw a card and roll a dice, my sample space will be both, right? Probability of the event is really that. It's the chances. So in P of the E, we'll put it again, is that number to win over the total. Okay? Theoretical probability really is that, isn't it? That's the theoretical probability. Okay? Before you even flip a coin, we know it's 1 out of 2. Before you even roll a dice, we know it's 1 out of 6. Before you even pull a card out of a deck, you know it's 1 out of 52, right? That's our theoretical probability, okay? Now, experimental probability is just, it's doing the experiment. Which we did with the spinner, right? We did with the spinner. Before we did the spinner, we made the spinner, and we said, okay, well, this is we did the whole degrees. We looked at the degrees. We said, okay, well, here's what I should get. That's experimental. Then we spun the spinner, right? We did the experiment, and we got slightly different answers. That would be the theoretical. That's the experimental probability. Now, odds. A lot of kids get messed up on odds. So write this down. The odds is going to be the chances to win, and they use this ... to the chances I can spell, I can, chances to lose, L-O-S-E. So let's write this down. To flip a coin, write this example down. To flip a coin, it's 50-50. Have you ever heard that 50-50, right?
A coin.
To flip a coin, it's 50-50. It's 50-50. Or it's 1 to 1. It's 1 to 1. Now there are 2 possibilities, right? There's a heads and a tails. But you've got 1 chance of winning and 1 chance of losing. Do you see the difference? Now if I want the probability of a heads, that's different. That's 1 out of 2. The probability is 1 out of 2, but the odds are 1 to 1. You got 1 chance to win. That's why people say 50-50. But they say it wrong. You guys say it all wrong. You say, hey man, come on, what are my chances to get heads? You'll say 50-50. Or you'll say, hey, what's the probability What's the probability of getting heads? You'll say 50-50. That's wrong. The probability of getting heads is not 50-50, but the odds are 50-50. Okay, so you see here the difference? Probability is the number to win over the total. Probability is the number to win over the total. Odds is amount of win to amount of losers. Okay, now think about this. Okay, so real quickly, if I wanted to say I want to draw a king, so I want to draw a king. I want to draw a king, right? So the probability of a king, P of a king, okay, probability of a king is 4 out of 52, okay? There's 4 kings, right, out of 52 cards. You guys agree with that? That's probability. But the odds are going to be 4 to 48. The odds are going to be 4 to 48 because you have 4 ways to win, and you got 48 cards that'll lose. Does that make sense? So if you do odds, you got 4 kids. I mean, if I said to you, you get $1 million if you draw a king. So you have 4 chances to win, but you got 48 chances to lose, don't you? See how the odds are different than probability?
That's way too high.
Okay.
Nobody would offer that.
No, because you'd probably lose. And, well, if you had to pay to play it, you probably wouldn't win, right? Yeah. Okay, now, what's this? Okay, this is your total sample set. So, P of A over the hat is this. Now watch. This is finding the other. So, in my kings, P of A would equal my 48 out of 52. Okay, I got to explain this really well, okay? Okay, this is not hard. This is super easy, but I can explain it really well, okay? A complement, okay? Got to listen. Complement, okay? Listen to what I'm saying. So, the complement is the other, okay? The complement's the other, okay? It's this easy, okay? If I want to roll a 3, I've got a 1 out of 6 chance. The complement is all the others, 5 out of 6. Okay? And let's just say 1 minus that, because the total event is 100%, right? So we get the 1 minus, okay? So probability of pulling a king is 4 out of 52, but the complement would be 48 out of 52 because that's the other, right? So to be the complement, it's got to make the total set. The total set makes the complement, okay? So you put the 2 together, okay? Let's see, what's another one? My spinner, okay? Let's say I got 4 colors in my spinner, okay? 1 out of 4 would be win, but its complement would be 3 out of 4 to lose. See the difference? It makes the total sample set, okay? All right, let's keep going. Now, let's look at the next page, all right? Let me find a pen here. All right. So, let's take a look at this. First of all, a stack of cards. Shh. Spencer, you ready? Ben? Shh. All right. Stack of cards contains 13 clubs from a standard of cards. You pick from the stack and flip 2 coins. Okay, what are the possible outcomes? You ready? Watch. Okay, possible outcomes. Okay. Now, first of all, how many? You've got 13 clubs, right? And you flip 2 coins. How many possibilities do you have on your coins? And the other coin. Now you can do a tree diagram with this, but it's kind of a pain. But to find out how many outcomes, you've got the total of one times the total of the other times the total of the other. That's going to tell you how many combinations you can get. So whatever 4 times 38 is, 52 is 13 times 4, 52. 52 possible outcomes. Okay, I'm almost done. I'm going to do 2 and 3. You guys are going to listen, all right? Now, number 2, you have a spinner with 1 through 5. So how many possible ways can you win? 5, right? 5. And you roll a dice. How many possible ways can you win on a dice?
6.
So it's just 5 times 6. There's 30 possible outcomes. Okay, now, if we want probability, then we would just take this and divide it by all of the possible outcomes, okay? All right, 3. When two tiles with numbers between 1 and 10 are chosen from two different bags, there are 100 possible outcomes, okay? First probability that the sum of the two numbers is not 10, and find the product of the numbers greater than 10. Okay, so first of all, we've got tiles, okay? Between 1 through 10 are chosen from two different bags that are numbered. So, find the probability that the sum of the two numbers is not 10, okay? I'm losing you, aren't I?
No.
Okay, I think I'll stop there, and you have homework to do, don't you? All right, stop there.